Envision gazing up at the night sky, where each star addresses a guide of probability. Presently, strip that sky of almost everything. No stars, no worlds, simply a mind-boggling vacancy. This is the KBC void, an enormous desert extending across 2 billion light-years. It's not only a shortfall of light, a significant secret opposes all that we assumed we had some awareness of the universe. Consider the possibility that this tremendous void district isn't a peculiarity but a sign, a vital aspect for understanding why we've yet to find any indications of intelligent life, why the universe's development doesn't make any sense, or even why our reality feels so disengaged. This is something beyond a disclosure. It's a test to the actual laws of cosmology. Might the KBC void be concealing the responses to questions humankind has been asking for hundreds of years? The discovery of the KBC void didn't work out coincidentally. It started with cosmologists planning the distribution of galaxies using a procedure called universe redshift surveys. These surveys measure how light from far-off galaxies stretches as the universe grows. When they gathered the data, they found something uncommon, a gigantic region traversing 2 billion light-years, almost absent of any and all galaxies. To place this into perspective, this void is so vast that it would take light, the fastest thing in the universe, more than 2 billion years to cross it. At first, many researchers were wary. The standard model of cosmology, which assumes the universe is generally uniform on large scales, seemed contradictory with such a void. It tested the very foundation of what we understood about how matter is distributed across the universe. Yet, repeated observations confirmed its presence, forcing scientists to rethink their models. The KBC void isn't the first vacancy of its kind to be found. The Boötes void, for instance, is another massive void, but at a mere 330 million light-years wide, it is dwarfed by the sheer size of the KBC void. What makes the KBC void even more intriguing is its location. It's not far from where our own galaxy resides. This raises significant questions about how such a colossal structure could form and how its presence affects how we might interpret the universe. Yet, the real mystery isn't its size or location, it's the implications. Might this void eventually explain why the universe appears to be expanding at conflicting rates? Might it be the reason we've yet to detect signals from intelligent life in the universe? The answers might lie in the edges, or the absence, of the KBC void. To truly comprehend the KBC void's significance, we need to explore its relationship with one of the greatest mysteries in cosmology, the Hubble tension. This phenomenon describes a puzzling disparity in how scientists measure the universe's expansion rate. The direct method involves observing nearby galaxies by measuring the light from specific stars, like Cepheid variables and supernovae. Cosmologists calculate distances and the speed at which these galaxies are moving away from us, which gives us a higher estimate for the Hubble constant, around 73 kilometers per second per megaparsec. The indirect method, however, focuses on the universe's oldest light, the cosmic microwave background, CMB. This flash from the Big Bang provides a snapshot of the early universe. By applying models of cosmic evolution, scientists predict a lower Hubble constant, around 67 kilometers per second per megaparsec. The gap between these measurements, the Hubble tension, raises questions about whether our understanding of the universe is incomplete. Here's where the KBC void comes in. Its size and relative emptiness create a gravitational anomaly. The void's lower density means less matter to slow down the expansion of space within it. Meanwhile, denser regions outside the void exert stronger gravitational forces, pulling galaxies outward and giving the illusion of faster local expansion. This difference could, to some extent, explain the higher values of the Hubble constant measured using the direct method. But what if the KBC void isn't unique? Recent simulations suggest there could be other enormous voids yet to be discovered, each influencing local expansion rates. If true, these voids could collectively distort our measurements, leading to the observed discrepancies. This hypothesis challenges our assumption that the universe is homogeneous on large scales, a cornerstone of modern cosmology. Moreover, alternative models, like modified Newtonian dynamics, MOND, suggest that voids like the KBC form more readily in a universe governed by altered gravitational laws, unlike the lambda CDM model, which relies on dark matter to explain cosmic structure. MOND posits that gravity behaves differently in low-density regions. If MOND is correct, it could reshape our understanding of both voids and the fundamental forces shaping the universe. So, is the KBC void an anomaly, or is it part of a broader cosmic mystery? Its very existence forces us to question the principles underpinning cosmology. Could it be the missing piece that explains the Hubble tension, or does it indicate something far stranger? Why should we care about a vast void region of space billions of light-years away? The KBC void might seem like a theoretical concept, but its presence addresses some of the most significant questions about our place in the universe and even our future as a species. Interestingly, the Hubble Space Telescope captured an image of the KBC void, a striking, eerie snapshot of the universe's emptiness. Rather than the typical vibrant clusters of stars and galaxies, the photograph reveals a sparse, almost desolate field of space, with a few distant galaxies dotting the darkness. This image isn't just a photo, it's evidence. It validates decades of theoretical research, showing that this enormous void isn't a mathematical concept, but a real physical region that challenges our understanding of how the universe developed. What's even more unsettling is the contrast between this image and Hubble's pictures of dense galaxy clusters, brimming with stars and activity. The void seems all the more profound, as if we're staring into an infinite pit, an indication of how unevenly the fabric of the universe is woven. So, what does this mean? First, the KBC void reshapes our view of intelligent life. If we truly reside in one of the most barren regions of the universe, it could explain the perplexing paradox of why we haven't found signs of other civilizations. Advanced life might thrive in denser areas of the universe, where resources like stars and planets are more plentiful. Meanwhile, the sparse conditions of the KBC void might create an evolutionary bottleneck, forcing civilizations to focus on survival rather than exploration or communication. Could this mean that technological advancements in worlds are a rare anomaly? Second, consider the practical implications for future space exploration. If humanity ever dreams of leaving the Milky Way, the KBC void presents a massive logistical challenge. The distances between galaxies within the void are so vast that intergalactic travel could require resources and technology far beyond what's currently possible. Even if signals from other civilizations exist, the sheer scale of the void could make detecting or interpreting them nearly impossible due to delays or signal degradation. Third, the KBC void challenges fundamental cosmological principles, directly affecting how we understand the universe. For instance, if voids like the KBC influence local measurements of the might need to be reconsidered. This could change everything from dark energy models to predictions about the ultimate fate of the universe. On a more personal level, the KBC void also forces us to reconsider how we view ourselves. If we are isolated in an astronomical desert, it highlights the fragility and uniqueness of human existence. It serves as a reminder that, even in the face of such vast emptiness, we have found ways to understand, explore, and question our universe. The void becomes a symbol, not of insignificance, but of humanity's ability to seek meaning in the unknown. Ultimately, the KBC void matters because it invites us to ask, are we the exception or the rule? Is our position in the universe a random accident, or does it reflect something deeper about the nature of life and existence? The answers to these questions don't just expand how we understand the universe, they redefine how we see ourselves within it. The discovery of the KBC void presents profound challenges to our understanding of the universe, and the stakes couldn't be higher. This isn't just about filling in gaps in our knowledge, it's about testing competing theories of how reality itself works. The KBC void's existence strains the limits of our current cosmological model, lambda CDM, which relies on the concepts of dark matter and dark energy to explain the universe's structure and expansion. If the KBC void can't be adequately explained by this model, it could highlight flaws in one of the most successful frameworks of modern cosmology. Enter modified Newtonian dynamics, MOND, a controversial alternative that proposes gravity behaves differently at very low accelerations, eliminating the need for dark matter. The KBC void could provide the perfect testing ground for these competing theories. MOND predicts faster formation of large structures, like voids, and could explain why such an enormous region exists. But adopting MOND would mean overturning decades of research and rethinking everything from galaxy formation to gravitational waves. What's at stake here is the foundation of physics as we know it. Are we ready to rewrite the rules of gravity? The implications stretch far beyond academic debates. Understanding the KBC void could revolutionize how we explore space. If voids like this one are common, interstellar travel becomes even more daunting. Future missions might need to account for vast regions with minimal gravitational resources, where spacecraft could drift for centuries without reaching another star. The challenges posed by the KBC void extend even further. Understanding its true nature could push the boundaries of both observational and theoretical astrophysics. For one, any shift in our cosmological model would have a cascading effect on numerous other areas of science, from dark energy and dark matter studies to the search for extraterrestrial life and the understanding of gravity. If voids like the KBC are more common than we realize, our current models of the universe might need a fundamental overhaul to account for these colossal, almost empty spaces. Furthermore, the KBC void's existence might have profound implications for the long-term future of humanity. As we develop more advanced technologies and methods of space exploration, the obstacles presented by such vast empty regions could reshape how we approach interstellar travel. The void may not only be an empty space, it could be a defining feature of the universe's larger architecture, forcing us to rethink the distances between galaxies, the forces that shape them, and the very laws that govern the cosmos. The mystery of the KBC void also raises existential questions. If we truly exist in one of the most desolate regions of space, isolated from other advanced civilizations, what does that mean for the future of human exploration and survival? Could it explain the so-called Fermi paradox, the apparent absence of other intelligent civilizations despite the vast number of potentially habitable planets in the universe? Or does it suggest that advanced life forms are simply concentrated in specific regions of space, leaving vast areas like the KBC void sparsely populated? The ongoing study of the KBC void might provide more than just answers to these profound questions. It could also lead to groundbreaking discoveries about the fundamental nature of the universe. As we probe deeper into this enigmatic region, we might uncover new insights into the forces of nature, the origins of cosmic structures, and even the fate of the universe itself. The KBC void, and similar cosmic anomalies, could become the keys to unlocking new theories about spacetime, gravity, and the overall structure of the cosmos. Ultimately, the KBC void stands as a testament to the complexity and mystery of the universe. It challenges our assumptions, forces us to rethink everything we know, and opens new frontiers of exploration. In doing so, it reminds us that, in the grand scheme of the cosmos, there is still so much we have yet to understand. The answers to these questions might not only reshape how we see the universe, but also how we view ourselves, our place in the vast expanse of space, and our role in the larger narrative of existence. The KBC void is, in the end, not just an empty region of space, but a symbol of the mysteries that lie ahead, waiting for us to discover. As we continue to explore the implications of the KBC void, it becomes clear that its study will require a multidisciplinary approach, blending cosmology, physics, and advanced technologies. Theories will evolve, and new observational techniques will be necessary to unravel its true nature. The future of astrophysical research may hinge on our ability to understand this strange and vast region of space. Scientists may need to rethink how they interpret data, recalibrate their methods of measuring cosmic distances, and re-examine existing assumptions about the homogeneity of the universe. The KBC void may also highlight the limits of current technology. As we venture further into deep space, we will be confronted with the sheer scale of the universe's empty regions. Our ability to gather accurate data from these vast areas may require more sophisticated instruments and perhaps even new types of telescopes capable of detecting the faintest signals from the edges of the void. These advancements could dramatically improve our understanding of the universe's structure, influencing everything from the search for dark matter to our understanding of the cosmic microwave background. The study of voids like the KBC might also spark a new wave of interest in the search for extraterrestrial life. If we are indeed living in one of the more barren areas of space, it raises the question of whether other regions are more densely populated with advanced civilizations. This could drive new initiatives to study the conditions that favor the development of life, prompting scientists to explore areas of space beyond the well-worn paths and search for habitable zones that are not easily detected. If the KBC void has taught us anything, it's that the universe is full of surprises, and answers may lie in the most unexpected places. Moreover, as we delve deeper into understanding voids like the KBC, we may uncover insights that stretch the boundaries of human imagination. Could the voids themselves play a role in shaping the overall fate of the universe? Could these vast empty regions influence the very expansion of space-time? What role do they play in the cosmic dance of galaxies, dark matter, and dark energy? The KBC void may be just the beginning, a starting point for a new era of cosmic exploration that challenges our assumptions about the very fabric of reality. While the answers to these questions remain elusive, the discovery of the KBC void provides a powerful reminder of how much we still have to learn about the universe. It underscores the complexity of the cosmos and the mysteries it holds, mysteries that, if understood, could profoundly change the way we perceive our place in the universe. As we move forward into this uncharted territory, the KBC void serves as a symbol of both the vast unknowns that lie ahead and the potential for discovery that awaits us. In the end, the exploration of the KBC void is more than just a scientific pursuit. It is a journey into the very heart of existence. It challenges us to confront the deepest questions of our origins, our purpose, and our future. As we seek answers to the mysteries of the universe, we may find that the journey itself is just as important as the discoveries we make along the way. The KBC void is not just a region of space, it is a profound invitation to look deeper, to explore farther, and to embrace the unknown with curiosity and wonder.